the queries that we're doing so that you can replicate them if you want. So the right way to do it would be to capitalize it, but I have to admit I'm lazy. So select star from student will get the job done. And as you can see, it prints out the entire relation. Now what I want you to do is print out the last name and GPA of everyone whose GPA is greater than or equal to 3. So let's say we want to give honors to anyone whose GPA is greater than or equal to 3. So print out the last name and the GPA of anyone whose GPA is greater than or equal to 3. I said greater than or equal to 3, although I don't really care. It does, whether Wile E. Coyote gets in our honors list or not. Okay, so it would be select. In this case, I asked only for the last name and the GPA. And watch this. Notice that last name and GPA are capitalized, but I'm not capitalizing them. Where GPA is greater than or equal to 3.0. Really? That didn't... No, I have an error somewhere. Where's the error? Oh, someone tell me the error. That's good. Tell me, what's the error? Yes. I forgot the from statement, so it has no idea where I'm selecting it from. So I have to say from student where GPA is greater than equal 3.0. And as you can see, it totally was okay with my not getting the case sensitivity correct. Okay, that's all nice, but let's say that we want to give the award to the top 3 people. So we want to sort it by GPA. So now, do the magic sauce. By the way, it doesn't have to all be on one line. If I hit return, it gives me an arrow, so I can continue on another line. So do the secret sauce that is going to put it, if I want the top 3, think about it. Do I want it in ascending or descending order? Think about that. Don't blurt it out. Think about it. If I want the top 3, should I sort in ascending or descending order? Okay, it is order by GPA and descending. There we go. Okay, so order by GPA descending. Okay, now let's do courses. Let's select all courses that have the word Claxton in them. So I want all courses that have Claxton in them. Now, Here's something that can help. There is a command called describe. Actually, there's two useful things. First of all, if you want to know the names of all the tables in your database, show tables will give you a list of all the tables in your database. So that's useful if you forget the name of your tables. If you forget the names of the attributes in your table, the describe command will tell you the names of all your columns, their types, whether a null value is allowed, whether it is a key, what its default value is. Okay, those are all things that I could have provided as well. I could have made one of them a key. I could have given them default values. So what I want is for you to print out all courses, so all their information that are being held in Claxton. So anything that has Claxton in it. Don't just say where location equal Claxton. Anything that has Claxton in it, because maybe it would be 121 Claxton, 323 Claxton, 528 Claxton. So anything that has the word Claxton in it. Okay, so let's look at it. It's select star, because we're printing all the information from courses where location like is what we're after. And I said any fragment, so Claxton, and then I put percent signs both in front and in back. And those give me the two courses. Now I know in this case I didn't have room numbers, but the reason I wanted you to put percent signs before and after Claxton is because oftentimes you might have the room number as well. Although, someone tell me, is that a good idea to put the room number in with the location? No. Why? Pardon? Makes it what? It's mixing data types in some sense. It's a compound attribute. It's really two pieces of information, so you're mixing data types. So you really have a location in a room. So ideally, it would be building and room. And location would kind of be this compound attribute that refers to both building and room. So typically, you try to explode compound attributes into more primitive types so you don't mix the data types. Okay, now let's do student courses. So take a look for a moment at student courses. And now what I want you to do is to print out the all student IDs where the score is between 60 and 90. So I want all student IDs, and they're actually, let's say I want student ID, course ID, and score. So three attributes: student ID, course ID, and score, where their score is between 60 and 90. There's the query. But you have to figure out how to express it in SQL. Inclusive. Okay, so to do it, we're going to select student ID, course ID, score from student courses, and it's going to be where scores score between 60 and 90. So that gives me all of those students. Now, it's kind of annoying that we don't have the students' names, right? Ideally, instead of their IDs, we would like to see what their names are. Do we agree? So today we're only doing single relation queries, and we can't get at it. On Thursday, we're going to go over multi-relation queries and show how you can join two relations together in order to get that kind of information. But today we're stuck with not having quite as informative results as we might like. Okay, the last thing I want you to do is to find the minimum and maximum GPA. So find the minimum and the maximum GPA. So print out the minimum and the maximum GPA. Okay, so select min GPA, max GPA from student. Okay, there's our query right there. And that gives us the min and the max. So, yes? So I just was trying that experimentally. That's why I took it down for a moment. I actually tried that. I decided to, it says you can't do it according to the standard. So I thought, what's it going to do? Will it execute the query? Will it give me an error? So I tried it. I said select min GPA, comma, last name from student. Okay, and this was the result I got, 0.92 van der Zanden. Is that right? Look at it. In fact, van der Zanden has a 3.92 GPA. So what it did, if you look at the relation, select star from student, it just took the first row and put that name in. So it was useless. I actually have to admit, I have to think about it. I'm not sure off the top of my head how to print out the student with the minimum last name. I will think about it and come up with it. Yes, Annika. No, it's not. So one thing, okay, so Annika was trying to say, can you somehow, in effect, put the aggregation function into a where clause, and you can't. So one thing you might like to be able to do is say select, say first name, last name from, say, student. You might like to be able to say where min GPA, okay? But you get invalid use of group function, and what that means, so min is a grouping function. It's an aggregation function, and you're not allowed to use aggregation functions in a where clause. So it doesn't work. It's just, that's part of the standard. You can't do that. Yes?
I guess it would make sense to, like a two-part query where you grab an GPA and look at the student, because that could be
You're going to do that. So one way to get the minimum, so I could certainly start by saying select min GPA from student. That gives me the minimum GPA. Now I can say select first name, last name from student, where min GPA equals 0.92. And now, what? Oh, sorry. Yeah, whoops, whoa. Yeah. Where GPA, there, so it's Bugs Bunny. That will work. Okay, so, and I believe this will work. We haven't gotten to subqueries yet, but to give you a preview, I think this will work, so just a second. This is always dangerous to try stuff on the fly, but what the heck. Yep. So this is the way you get it done. It's called a subquery. We haven't yet talked about subqueries. I don't think we even get to subqueries until next Tuesday. But what I did was, this is the subquery right here. It returned the minimum GPA, and then that allowed me to get Bugs and Bunny out of it. Like I said, we're not going to go over subqueries until next Tuesday, so don't worry about it. It's not on the current homework assignment. By the way, there is this homework assignment starting today that you can start getting started on. Okay. Anything else I wanted to say? Okay, so that's all well and good, but let's say that we now want it to, let's say we want it to print the enrollment in each of our courses. So we have student courses, okay? And if you look at it, if we say select star from student courses, we have a whole bunch of students. So let's say we want the number of students taking each course. So the number of students taking CS 140, the number taking WE 300, the number taking Accounting 102. You can try to say select count star from student courses, but that's just going to give you the total number of tuples in that table. It's not breaking it down by course. So that's the next thing, is that there is a way to group tuples in order to do some kind of aggregation function on them. And the key word is group by. So the group by will aggregate together all tuples with a common attribute value. So for example, if I say group by course ID, it will group them all by similar courses. So let's actually do one. Select, what's the name of it? Course ID, I believe. Yes, course ID. Count star from student courses, group by course ID. And now I get the enrollments for each of my courses. So the group by said to group together all tuples with a common course ID, and then to count them. And now, notice I was allowed to use an extra attribute in my select clause. Remember, previously, I told you it wasn't legal to include other attributes in a select clause if the select clause had aggregation functions. Now I'm telling you the exception. The exception is that any attribute used in a group by may also appear in your select statement because it's grouping on that attribute. So it makes sense to print out the values of that particular grouped attribute, in this case course ID. So that's your exception, is that any attribute that occurs in a group by may also appear in your select statement. And because count star, I said really I wanted it to be enrollment, so I'll just say actually count star as enrollment, and now it prints more nicely as enrollment. Okay, let's say that I want to find out if there's any particularly difficult course in our curriculum. What I would like you to do now is print out the average score for each course. So based on what you see there, try to write a query that instead of printing out the enrollment for each course, prints out its average score. Okay, so It's pretty much what you see there, except that rather than count star, it is average. See if we can use average star. I'm not sure I can. Nope. Have to actually say average, and I have to say what I'm averaging, which is score. There we go. Do not ask me how to format it nicely. I have zero idea. Okay, usually you're not doing this from the command line. Usually you're doing it from a scripting language like PHP or Python, and then you're just taking these results and you'd be printing it out using a scripting language, and then I could tell you how it's done. So that's usually how I interact with databases, is via PHP. At any rate, this gives us the score. Okay, notice something. This always gets me, so pay attention. Notice that the results were sorted by course ID, right? So people get it into their head that group by can be used to sort tuples. And they turn in homework assignments where the question asks them to sort the tuples by last name. And instead of handing in a query that says select last name from, say, student, order by last name, instead, what I get is a homework assignment that looks like that. And it seems to work. And when the TA deducts points, I get anguished cries saying, but it worked. It produces the result. What more do you want? It's wrong. Okay, group by is used with aggregation functions. I know as a side effect that it can produce an ordered output, but do not use group by to produce ordered output. If you want ordered output, use order by. Group by is reserved for aggregation. You use group by when you want to deal with aggregation functions. If you want to sort your output, you use order by. When you get points deducted for trying to sort using group by, this is a violin. Okay, my heart's bleeding for you and giving you no points back. Okay, so please observe that distinction between order by and group by. Yes?
Is there a way to order by the average score?
Yes. So, I believe so. So we will say select course ID, average score. Now as, we'll call it average, where order by AVG. See if that, there we go. So just name the column and then order by it. And now it's by average. Right. So I could have also just said AVG score like that. Just more readable the other way. But you're absolutely right, Tyler. Okay. Now, it's not really that I want a listing of all. Remember I said we're interested in courses with low scores. I really don't want to paw my way through all the courses at the university. I maybe am only interested, say, in courses with an average score less than 75. So really, I would just like to print out those courses whose average score is less than 75. Well, what is the most logical thing to do? The first thing you're probably going to think about doing is saying where average is less than equals 75, and then you remember after Oh, it didn't work. Dr. van der Zanden said I couldn't put aggregation functions into my where clause. And I tried to fake it because I renamed the column as average, but SQL was too smart for me. It figured out I was trying to pull wool over its eyes, and it still gave me the error message. But there is a nice having clause, so let me show it to you. Okay, so the having clause allows me to, it's like where, except that having allows you to use aggregation functions. So there is a distinction, we'll get to it in a moment, but having allows you to specify aggregation functions as your filter. So having is used in conjunction with group by. Okay, so what can appear in a having clause is anything that has to do with your group by or aggregation. So aggregation, I could also say and course ID in, or let's say course ID like. We'll get all our CE courses. Okay, so now I got my CE courses only. So in a having clause, I can have anything that, any attribute that's in my group by and anything in my aggregation. Okay, so let's just go up here and do a quick review of all this. Let's see if I have my having. Okay, so having is meant to, here's our distinction. Having is designed for use with group, and it filters groups, whereas where filters individual rows. That's the crucial distinction. Having filters groups, where filters individual rows. And you can see at the bottom, column names in having must also appear in the group by list or be contained within an aggregate function. So there's a restriction on what can appear in having. There's also a restriction on what can appear in where. You can't put an aggregation function into where. And in having, it can have an aggregation function, but it can also only have attributes that are either in an aggregation function or that are on the group by list. So they each have a role to play. And the where clause gets executed first. Let's see if I have a, let's see, nope, okay. So I don't have an example with both, but it's okay to have both a where clause and a having clause in the same query. And if that happens, the where clause gets executed first and filters out the rows you want, and then the having clause is applied to it. So let's say that I have it in for someone, and the president asks for all courses that where the score is less than or equal to, the average score is less than or equal to 75, and I have it in for everyone. I'm just in a bad mood, so I say where score is less than or equal to 75. Actually, let's make it less than equal 60. What that does is it guarantees that everyone's going to have an average less than 75 because I'm filtering out all the rows where the score is greater than 60. So first, I'm getting only the rows that have a score less than or equal to 60, and then I'm getting their average. Whoops, what did I do wrong? Oh, I think my things are in the wrong order. Yeah, my where clause has to be first. SQL is picky as to where the order of things. I have to put my where clause before my group by. Score is less than equals 60. There we go. Wow. That took down some stuff. Although it's interesting because that actually didn't filter everything out. That's unusual. Does anyone notice something strange about this result? So let's look at all the select course ID from student courses. There's a lot of them, right? So the question is there another course? Let's look at all scores that are less than 60. So select scores and course ID from student courses where score is less than or equals 60. Oh, that's why. Okay, let's try something here. Insert into student courses, values, student 6, course ID is, I'm going to put in some bad values for, can someone do a quick describe? Which column is first, GPA, letter grade or score? Do a describe table for me. Which is first? Grade is first? Thank you. A, and we'll make it be 93. Oh, shoot. Okay. What I'm doing is inserting some, I'll show you in a moment. And I'm going to do another one, give them a score of 40, an F. Actually, I'll give them a score of 60. Okay, so what I did was, if I do my original one, how come CS3, there we go, CS302, just a sec, do my original. Okay, here's my original query. So I am selecting all courses whose average is less than or equal 75. CS302 doesn't show up, right? Now I am in a bad mood, so I modify it so I'm only selecting scores that are less than or equal to 60. Now CS302 shows up because I excluded that A score from the sample. So the where clause gets executed first, and then the having clause gets executed only after on whatever remains. Okay? So questions? Fantastic. So next time we're going to tackle multi-relations, so queries involving multiple relations, and we're going to tackle insert, delete, and update, which are quite trivial. And you can get started on the homework assignment. You probably can't finish it because not all of the queries are single relation queries, but you can certainly give it a try.